All right, so we are going to talk about accuracy and precision. It won't take us very long. We kind of already hit on this before when you did the density activity when the sub was here. But we're just going to give you a little definition for accuracy and precision. It should be page 14 in your packet where you're going to take some notes. It's not a lot. And then you are going to have to do kind of a little quiz afterwards. You can use your notes. Um, and that is on my website as well. Okay, so make sure you turn to page 14 in your packet. All right, so new vocabulary. This is what you're going to put down for the definition of accuracy and precision. If I go too quick, just pause the video so that you can see the definitions. Okay, so accuracy, probably already know this, but how close a measurement is to the correct or accepted value. All right, and we're going to go into a little bit more detail on how you see that, but accuracy, how close a measurement is to the correct or accepted value. All right, and remember, if I'm going too fast, pause it. Precision, on the other hand, is how close a measurement is to other measurements of the same thing. So when you are taking multiple measurements of something, how close are they together? All right, and the last one, you guys already know the significant figure is just a meaningful digit in a measured value. So all certain digits plus one that is estimated. So you go to what you know for certain, estimate one more. Okay, so those are our three vocab words. Significant figures, you don't need to write that in your notes. All right, we already have that, but just as a little reminder when we do measurements. Okay, so accuracy, what does it mean? It's what is expected, right? What is it supposed to be? So how I remember it, accepted has ACC in the beginning, well, so does accuracy, right? And they kind of sound a little bit alike. So that's how I remember what accuracy is. Okay, so that's a little hint, guy. We're going to use a concept of a bullseye. All right, so on the left, that is inaccurate. We hit the bullseye straight on. Okay, whereas not accurate, we're hitting it all over. We're nowhere near that middle. As you can see, a lot of the shots have been outside even the target. All right, so that is not accurate at all. Left, accurate, hit right in the middle. Precision, how I remember that is precision, there's a RE right at the beginning, the second and third letters. Well, it is to be repeatable. So precision and repeatable. Are we getting the same things over and over and over again? Okay, so again, back to our target. On the left, it is precise. All right, they're all really close together, or on the left, they're all really close together, whereas on the right over here, they're not close together at all. Okay, they're all over the place. So that is not precise. Okay, so we're going to look at some data. We have a weight that is we know for sure it's 1 kilogram, but I wanted you guys to measure it out. So we look at this. Trial 1, it was 3 kilograms. Trial 2 was 2.1 kilograms. Trial 3 was 0.2. All right, is this precise and or accurate? Well, if you think about it, precise is meaning they're close together. Well, these are not close together at all. So precise, not going to happen. All right, accurate, we know that the accepted or the correct mass should be 1 kilogram. These aren't anywhere near 1 kilogram, so it's not accurate either. All right, so this set of data, those students just must have been off completely. Okay, our next group of students, they found trial 1 was 1.0, trial 2 is 1.1, trial 3 was 0.9. So precise, yeah, they're all really close together. They're only a couple 1/10 off, okay, from each other. All right, accurate as well, yeah, they're all right around 1 kilogram, so it's accurate. Okay, the last one, they have 2.3, 2.4, and 2.3. So these measurements are all close together. Repeatably, they're all close. So precise, yes. But accurate, no. They're not close to 1 kilogram. All right, so you can have something that is accurate or precise, but not accurate. All right, this would mean that something like with the balance is wrong. There must have been something off with our balance. If we get the same number multiple times or close to, but we know it's not correct, that means that there must have been something wrong with our balance. Okay, and this leads us to percent error, which you have done. All right, and I simplified it a little bit more. So this is the equation that you're going to be using for percent error. You have your accepted value minus experimental value, or error, okay, with absolute value. So remember, if it's negative, you turn it to positive. If it's positive, it stays positive, okay? Divided by the accepted value. So divided by the value that we know is correct, all right? And usually this is one that you get from a textbook, the teacher gives you, whereas the experimental value is what you found out in the lab. All right, multiply it by 100 because it is a percent, okay? Here's our equation. It's also in your notes, so make sure you read through that, okay? So while we're reading this problem, all right, so the density of tin is this, where the density of aluminum is 2.7. After measuring the mass of the volume of the metal, you calculated it to be 2.9 grams per centimeter cubed. So that leads you to that it is metal is aluminum because it's fairly close to aluminum that was given to us. All right, what is our percent error? So we go back, look at our equation. Well, we know our accepted value was 2.7. All right, I gave that to you. You could find it on your periodic table, things like that. Experimental, what we measured in the lab, we found out that it was 2.9 grams per centimeter cube. All right, so we just plug it into our equation. We found out that it was 7.4%, which is not bad. Okay, we can handle that. All right, so that's percent error. We've dealt it, but we've used it before. Okay, the last thing that I'm going to talk about, and I want you to put this down in the summary section, all right, is that we have what's called quantitative and qualitative data. All right, if it's quantitative, that means that it's describing like color, odor, shape, other physical characteristics. This is basically observations that we see. All right, whereas qualitative, it's numerical information. So how big, how small, how tall, how fast. We use qualitative for numbers. I have this messed up. Okay, quantitative is the numbers. Qualitative it describes the quality of your information. Okay, so qualitative, so hopefully you haven't written it down, describes the quality. What does it look like? Okay, where quantitative describes a numerical value. Okay, because I remember quantitative N, if it has an N in it, then it's telling us the number. Quantity, okay, we tell how much we have. All right, so make sure you have these written down in your notes. If you have any questions, please let me know. You will need this for the lab that we're doing on Monday. Okay? Make sure you do the little quiz at the end. All right? Or after you finish watching the video, you can use your notes. Okay? Have a great day or great night whenever you're doing this. Okay? Okay?